Okay, so it says a farmer wants to build two fenced off sections within his field, one shape of a rectangular shape and the other one is of a square. So let's do the square. And then let's do the rectangular shape. And then it says the square must be equal to the width of the rectangle. Uh-oh. Okay. And it's still not quite perfect, but all right, so the width, that's close enough. Just imagine that they're perfect. All right, so it says the shape of the rectangle and the other shape is a square. The side of the square must be equal to the width of the rectangle, which is x feet. So this is x, and this is x, and then this is x too, because of the square, all the sides are the same. And then it says the length must be 50 feet longer than the width. So this would be x plus 50. Okay. So then the farmer wants to build two fenced-in sections that has an area of y square feet. The difference of the area of this field in the area of the fenced, the square section, needs to be at least 1,000 feet. Okay. In addition, the sum of the fenced-in areas must be less than the area of the field. Which points are viable solutions? Oh, so they did the work for us. They figured out two inequalities, and so basically we need to find this because they're inequalities. We just need to graph these and find points that will work. So the way this works is we're going to graph this on our graphing calculator in just a second, but I just realized there are multiple choice answers, and we're going to copy and paste those in here. So these are the multiple choice answers, and we have to see if these answers show up in our shaded region when we graph this. So the first thing I'm going to do is I'm going to turn on my handy dandy calculator. Now graphing inequalities on a calculator is not that hard, but it's not easy either. Basically what we're going to do is we're going to enter in the equation just like you see it, but we're going to change it to an inequality. So x squared plus 1,000, oops, plus 1,000, oops. That's the first inequality. But now for this, when we do an inequality, there's a couple things. If I hit enter and I scroll down, I'll leave it red, but I'm going to scroll down here. Now that means greater than. This means less than. And this is the dotted, but we want greater than, because above the line, greater than y means above, right? So whenever we do greater than, we're going to shade above the line. Okay, so I'm going to hit OK. All right, so that's going to shade one way. Now I'm going to come up down here, and this inequality has a greater than or equal to. This one has a greater than. So when I go to graph, I'm going to come down here and I'm going to make sure that there's a shading above. So I just hit enter. I scroll down here and I go till it's shaded above. So what this little symbol is letting me know is that I'm going to shade above the line when I graph the line. So I'm going to hit OK there. Now I've got to enter in that second equation, which is just going to be 2x squared plus 50x. Okay. Now where this comes from is the perimeter of the fence for both fences and the area that the one field needs to be. So this is the inequality for the area of the square, and this is the inequality for the perimeter of the fence. Okay, so there's that. Or actually, this is the area of the rectangle. So now when I hit graph, and I'll probably have to zoom out quite a bit actually. I need to figure out if these answers are in the shaded region. Okay, because if they are, then they're solutions, right? So I could have various lengths for these things. But what I notice is that the x values are all positive. The lowest one is 5. The highest x value is 30. So what I'm going to do is I'm going to go on my calculator and I'm going to adjust. I'm going to go second table set. Nope, sorry, wrong one. I'm going to hit window. And so I'm going to do 0 to 40 for my x value. And then, oops, the minimum is 0. Dang it. And then my maximum is 40. Now what I'm telling the calculator is your minimum value that you're going to show in the window in the x direction, we're going to go from 0 to 40. Okay. Now for the y value, if you look, the y values go, the lowest one is 1,000, 1,100 all the way up to 3,000. So my y value, I'm going to go down to 1,000 is the minimum. And the greatest one, I'm going to do about 3,500 because that's a little bit more. I want to go a little below, a little above. Okay. So then that's only going to zoom in on that. So now when I hit graph, this is what I see. So that's the first function. And this is the second function. So what I'm looking for are points on the graph where these two overlap. So the solutions to this is any point that is here on this graph. Okay. So I've got to look at this, and now I could look at the graph. Let me take a picture. Let me take a little screenshot of this, and we'll put it on the thing. Now you could do this algebraically too, but what I want to do is I'm going to enter in 30 and see if that's in both the blue and red. So what I do is I pull up my graphing calculator, and I'm going to go here and I'm going to hit trace. All right. Or I could just I could hit trace, or I could just hit the cursor. So if I enter in 30, oops, wrong one. If I hit graph and I go over to 30 like this, I've got 30. There's 30 and 30 comma 2000. Well, as you can see, when I get down to 2000, that's not a viable. And I'm going to move this so you can see the thing. That's not a viable solution. Right? So when I get to 30 comma 2000, clearly we're not in the blue region. So that's not going to work. That one won't work. So now let's try 10, 1100. So I'm going to pull this up. I'm going to move the cursor over to 10. And when I get close to 10, then I'm going to come down to 1100 and see if I'm in both. Now that one's hard to see, but I think that's right on the one line. So I think that's right on the first line. So what I could do is look at the table of values at 10. So if I go to table set and I start at 0 and my increment is 1, now when I look at the table, when I go down to 10, it's definitely a solution for both because y is greater than this. So this is a little confusing, but I'll explain it. The blue one is at 700. So that means from 700 on up is shaded. So yes, this one is a possible solution. So this one's right on the border right here, right? So this one right here is right on the border, but it's still both areas are shaded. So we've got 10 comma 1100 works. So that one works. And then let's try 5, comma 3000. So again, I'm going to go back to my graph. And I'm just going to slide over to 5. And 5, 3000. So if I scroll up to 3000, as you can see, that's in both of the overlaps. Okay, so that's right here somewhere. So that's 5, comma 3000. So that one works because it's in the blue and the red. Oops, one more 0. So that one works. 25, 2500. Now we're going to see if that one works. So we'll move over to 25 first. And then go down to 2500. So this one's going to be a tough one too, because I think that's right on that line. So what I'm going to do is I'm going to zoom in and see where we're at. Oops, zoom in. I'm just going to zoom in right there at that spot one time and see where we're at. So if I go over this way and I go down to 2500, so I think that one's right on the border. So if I look at the table of values, when we get to 25, this is going to be a tough one, but I'm glad it's there so that you guys know. All right. So here's the thing. The second equation, it's defined, the lower boundary is 2500. The problem is that my second equation does not have an equal sign. So if it's on the line, it doesn't count. We're not including values that are on the line. So that one doesn't work. So that one is actually right on the line. And because the inequality symbol doesn't include stuff that's on the line because it doesn't have an equal sign, we can't use that one. So the last one that we got to do, this is like 5 problems in one, is 20, 2200. So I'm going to move around till I get to 20. Second up. Am I still on the screen? Oh shoot, I gotta zoom out now. What did I do? It was 0 to 30. And we want 2200, so let's make this 1000. All right. Oh shoot, lost track of time. We gotta hurry up and finish this one. So we're gonna go to 20, oops, and then 2200. So as I get closer to 2200, we can see that it's gonna be in both regions, right? Yeah. So somewhere over here, we have 20, comma 2200. It's in both shaded regions, so that's a good answer. And that's it. So what does this mean? That means that I can make the side, I can make the square length like this x, I can do 10, and then the area will be 1100. I could do 5, and the area would be 3,000, and that's a viable solution for both, okay? Now these other numbers I could plug them in, but they're either right on the boundary, doesn't qualify, or they're on one boundary but not the other, doesn't qualify. It has to be in both shaded regions. And if it's on the line, it has to have the equal sign. If it doesn't have the equal sign, then we can't include it, okay? And that's it for that one. Well, guys, I'm